Hello everyone, today we're going to look at the derivative of logarithmic functions. So the very general case, log base b of x, if I want to differentiate it, I get 1 over x times log base b of e. Now if you want to know how this comes about, how you derive it, then you can look through the book in the section, but for now we're just going to assume that it's true. Now remember that log base b of e is a number. It's some number, depends on what b is. And just remember again that it's a number, it's not a function, it's not a variable. We're going to also look at the more general case, the derivative of log base b of u, where u is some function of x. So it's log base b of x cubed, or log base b of cosine of x, something like that. That just uses the chain rule, so we start off with 1 over u times log base b of e times du dx. So you differentiate it like you did before, 1 over u instead of 1 over x, log base b of e, and then you multiply it by the derivative of that inside function. Typically, our b is going to be e, so remember that ln is the same as log base e. And the really nice thing about this is that log base b of e is going to become ln of e, which is just 1. So that when I differentiate it, this guy over here is going to end up going away. And the derivative is just u prime over u. So 1 over u times u prime is the same thing as u prime over u. So it's the derivative of the inside function divided by the function itself. So this is the one we're going to typically see more so than any other log base. But we will see different bases come up every now and then, so we'll see a couple of them. So differentiate the following. The first one is ln of x squared. So again, it's ln, so the derivative is going to be the derivative of my inside function divided by the function itself. So 2x is the derivative of x squared, and then 2x over x squared. We can simplify this, and we get just 2 over x. As the next one, ln of sine of x. So again, it's ln, so the derivative is u prime over u. U prime is cosine, so I have cosine divided by sine. This I could further simplify into cotangent of x. As another one, we have log base 2 of x squared. So it's not ln, it's log base 2, and it's not log of a function, it's log, and then that log is being squared. So we have to start off with, how do I differentiate something being squared? So to do that, I bring down the 2, and then I have that function to the 1. So the first part of my derivative is 2 times log base 2 of x. And then I differentiate that function. So the derivative of log base 2 of x starts with 1 over x, and then we multiply it by log base 2 of e. So again, since this isn't e already, we have to multiply it by log base whatever it is of e. So we have 2 log base 2 of x times 1 over x times log base 2 of e. As another one, we've got x times ln of x. So here we have the product rule, a function times a function. So remember, to differentiate that, we take the derivative of one function and multiply it by the other. The derivative of x is 1. 1 times ln of x is ln of x. And then I add to it the derivative of the other function times the original function. Derivative of ln of x is 1 over x, and then I multiply it by my original x. And then, of course, I can simplify this, and I get ln of x plus 1. As another one, we have the quotient rule. We have x squared divided by ln of 2x. Quotient rule starts by differentiating the top, multiplying by the bottom. So we get 2x times ln of 2x, and then we minus the derivative of the bottom times the top. The derivative of ln of 2x is, remember, u prime over u. U prime is 2. U is 2x. So we're going to subtract 2 over 2x times our top, which is x squared. We'll divide this by the bottom squared, so ln squared of 2x. So just like with sine and cosine, if you have ln raised to a power, we like to put the power between the function and the argument, so that if I wrote down this, it's not being confused with this. So we have ln of x squared and ln of x squared. So we typically put the square in the middle. Again, just like with sine and cosine. This here we can simplify. We have 2 over 2, which can simplify, and x squared over x. So this becomes 2x ln of 2x minus x divided by ln squared of 2x. Nothing else in here can get simplified, right? I can't cancel my ln's because there's no ln over here. So I can't do anything to it. That is my final answer. And here's my last one. Log base 3 of x times ln of 5x cubed. So I have two logs that I'm multiplying together. There is no nice rule of logs that tells me how to do a log times a log. So I'm going to start off with the first part of the product rule. I have the derivative of log base 3 of x right here. 1 over x times log base 3 of e, multiplying it by my second function. Then I add to it the other one. So here is the derivative of ln of 5x cubed. It's the derivative of 5x cubed divided by 5x cubed. So 15x squared is u prime, 5x cubed is u, and then I'm multiplying it by my other function. And then again, I'm going to simplify. I have 15 divided by 5, that's a 3. X squared over x cubed, that's 1 over x. Both of these terms will end up with a 1 over x, so I'm going to pull that out and just make it a fraction. So I have log base 3 of e times ln of 5x cubed plus 3 log base 3 of x all over x. So that's just simplifying it, making it look nicer. Okay, so read through the book, try out the homework problems, and let me know if you have any questions. Good luck.